Hello, so this question is merge two sorted lists. So you're given two lists and both of them are sorted, but you want to combine them, you want to merge them into one linked list in a sorted list. So basically you have a, node point at here and here. So you compare the value. Even though they are the same, doesn't matter. So basically it has to be increasing order, right? So I'm going to compare, this one and this one. So this is going to be this. So let's just say A and B. So A and B. So does A less than B? No, right? Because A is actually equal to B, but I still need to what? Append my A into the merge list, and then I move on my next node, right? I move on my next node to 2, right? So this become my A. Does my A, wait, this is 1. Does my A, no, less than B? No. So I append my B value into the list. And then you keep moving, right when you append, when you add into the single linked list. So you have to make sure you need to change the pointer. So this is the pointer, right? So you're going to change the pointer from here to here, and then change the pointer from here to here, and then change the pointer from here to here, and change the pointer from here to here, something like this, right? Alright, so you will become this. So basically you want to change the pointer. So we're not making a deep copy of the list node. We just access the value, access the address, and then we change the pointer value. Alright, so in this question, I'm going to talk about, two solutions. One is iterated, and the other one is recursion. So the iterated should be straightforward. I create a dummy node, and then I create a pointer, traversing all the way, from the beginning to the end for the merge purpose, right? For the merge purpose. So at the end, I need to return dummy.next. This is because I need to traverse my current pointer with the list 1 and list 2, right? This one, well, this one is not equal to null, and list 2 is not equal to null. I need to compare the value, right? So if list 1 is less than list 2, we need to use the list 1 value, right? So it's going to be current.next equal to list 1, and then I'm actually, move on my this one.next, right? So this is the if statement, and the else statement is going to be what? List 2, right? Then everything afterward, we need to move on my current pointer. So it will just keep moving forward every single time, right? And then at the end, I need to make sure does my list 1 is empty, because it will break out the condition if either one of them is null, right? We have to make sure there is something value in the list 1 or list 2. So we can just make sure if list 1 equal to null, I'm gonna say, okay, current.next equal to list 2. I don't care the remaining value, but it's gonna be list 2. If not, I'm gonna append a list 1. If both of them are null, it's definitely point at null. So that will be it, right? So let's move on. Oh, so yeah, should be equal. All right, submit. Should be okay. So time and space are straightforward. This is a space. I would say constant. This is the time. You are traversing all of the value, the nodes inside the list 1 and list 2. But if you notice that this is the end, right? The end condition. So it's going to be the minimum between this one and this 2, the minimum length. So if this 1 is shorter than this 2, so the time complexity is all of L1. If list 2 is less than list 1, its time complexity is list 2. Because once you break out list 1, you basically point your current.next to the other list node, and then you will be able to return the head, which is dummy.next. And yeah, that will be it. And then let's talk about the recursion. So we can use a recursion solution to solve it, but it will be a little bit challenge for you to think about it. So if this one, so we need to append, right? So sorry, we need to keep traversing based on the next pointer, until the list one is null or list two is null. So basically, if list one is equal to null, you want to return whatever you have for list two. So this is a concept, right? So it will be the same. List two equal to null, whatever you have for this one. All right. So now we're checking the value because these are the base case. All right, checking the value. If list one value is less than list two value, then I basically say, okay, now I'm pointing my list one next equal to the recursion for this, right? So the next pointer you will call is going to be list one next, and then list two doesn't change, right? So now once you complete, you return this one, and then else, you know, it's going to be the same thing, but this is going to be list two, right? And you're not actually traverse this one next, but list two next. So this will be it, right? So just want to make sure with you, if you have this one and then return statement over here, you don't need an else. Make you happy for that. So something like this, right? So let me run it and submit. Okay, so time and space, you know, time is definitely now you're traversing every single one of them, right? You traverse every single one. It does not contain like the minimum length, so it will be the maximum length between list one or list two, right? So I would say it's, you know, just all of them. So space is constant, right? If you are wondering what's wrong with this one, it's going to be this one next, this pointer, based on the next pointer, which is going to be 2 or 1. So let's look at this. So we already know 1 and 1. We compare 1 and 1. Does 1 less than 1? No. Okay. So basically, this will be this 2. This 2 next. So this 2 next. This one, this value, is going to be checked. So let me just redraw a little bit. So this one, the next pointer is going to be equal to what? The value for this one or the list 2 next, which is going to be this one, right? So you have to know that what you are comparing. So my pointer is either pointed at this one or this one, right? I need to change my pointer for my next, and then you just keep doing for the rest of the logic, and then this will be the solution. So if you think this is pretty good, you know, leave a comment, something like this, and I'll talk to you later. Bye.